No question. So, good morning. Before we start, I would like to know a bit from you what is your background. So maybe we can start from you.
I'm a physicist. I work with mostly molecular dynamics and density functional theory. So my interest in high performance computing is basically running massively parallel code at highest speeds possible for large systems of in the nanoscale, basically.
Which programming language do you use?
Excuse me?
Which programming language do you use?
I basically use Python mostly.
Python.
The code that I run is LAMPS, which is I think in C++, and then Quantum Espresso, which is in
Fortran. Okay. Thank you.
Okay, so I'm an engineer and I'm doing my PhD in material science at Misano. I'm a bit of an outsider because I'm an experimental, but still I'm trying to. I use Python to do some of my stuff, and he's doing the DFT part of my stuff, so I want to understand and learn more.
So as programming language, you know Python?
C,
okay, great. Thank you.
I'm a student, PhD student. I'm working about the biomedical part. I'm using C and MATLAB and Python to program an arterial and venous network.
Okay, thank you. Go.
I come from engineering.
Yes.
But I study also the biological simulation, so I found interesting this course of
Okay.
high performance computing.
And which programming languages do you use?
C++ and a little Fortran.
Great. How about you?
I'm a researcher and I am a hydrologist, so I mainly solve differential equations using different programming language. I use Java, but I'm a little bit experienced with Fortran as well.
Okay, and how about C and C++?
I can
So and
read,
so.
but I never program. I can read and understand.
Okay. So, I'm sorry, I stopped you.
I come from engineering. I'm a geologist too. I'm doing mainly stochastic modeling for groundwater resources, taking into account heterogeneities. I started with Fortran 77 many years ago, and now I'm working with Fortran 90 and Python too. I started a couple of years ago using Python
And
interface to Fortran programs.
And do you have some experience with C and C++? No. Okay. Thank you.
I am Mikko from the IT staff from engineering faculty.
Okay.
And I have past experience several decades ago with C. And nowadays I don't develop and program anymore because I'm more on the technical part
Okay.
than programming.
Okay. Thank you.
I'm a PhD student. I'm mainly working on deep learning approach for diagnosis in image analysis. And I use Python, TensorFlow. Yeah, with the parallel processing, I use the university cluster and they are GPU, so I want to use more than one GPU.
Okay. Experience with C and C++?
I haven't used it recently, but yeah.
Okay. Okay. How about you?
I'm a computational biologist. I work with sequencing rates, so my goal here is to make my pipelines faster. I use mainly R because I do high-level statistics most of the time. Then I use Python if I need something more powerful, for example, for machine learning. And I've seen some C and C++ code because R interfaces with C. I modified it, but I never actually wrote out all script by myself.
Okay. Thank you.
So I'm a computer scientist and I'm working on my PhD in computational biology. I work with Python.
Oops. I'm sorry. Sorry, guys.
Master in Python and Bash. I have some experience in C, and I'm looking into Julia.
Okay, thank you.
I'm a PhD student in physics. I work on cosmology, and I know a bit of Python, but mainly I do C.
Okay, great. How about you?
I'm a PhD student in computational mechanics, and I work mainly with C++, but I also work a bit in MATLAB, Python, and Java.
Okay, thank you. So from tomorrow, lectures will be given, will be rely on C. You will see how to optimize, benchmark, parallelize C codes. So I was asked eventually to provide some background, some a bit of knowledge of C if needed. From what you have said, I suggest apart from few of you, all of you are comfortable with C. So if you are okay, I will spend a bit more time in explaining bash scripting, a bit more on Git, and eventually, if you have enough time later this afternoon, we provide an introduction to C. Is it okay for you? Yes, no? Maybe. If not, we can rearrange. Okay. No? Okay. So, yesterday we have seen some shell commands. Okay. Did you appreciate the shell? Or do you still think that a graphical user interface is better than a text-based interface? Come on, don't be shy. Who thinks that a graphic user interface is better? No? Okay. You think?
No, you are the only one.
No.
You mean an IDE with a terminal inside, or?
No. Say Windows versus Linux. Say, put this way. Windows versus a Linux terminal.
I prefer Linux.
You prefer Linux, okay. You prefer.
It remembered me when I was young.
Okay, great.
I prefer Windows with Windows Service Linux instead.
Okay, great. So I don't need to convince you then that a shell is much more powerful than a graphical user interface. And Bash is very powerful, okay? Of course, it's not meant to be used as high-performant language, okay? If you need to go fast, you need to crunch very big numbers, very big data, you may need to go for a compiled language like Fortran or C and C++, okay? Eventually Python, but when Python calls routines written in Fortran or in C and C++, like NumPy, SciPy, scikit-learn, they are all of them are written in one of these language, okay? But the shell, Bash, can be very handy because you can write very compact codes. Very few lines can perform difficult tasks. In 1986, the journal Programming Pearls asked to Donald Knuth. Do you know who Donald Knuth is? You know it.
Yeah.
Who doesn't know Donald Knuth? So Donald Knuth is the inventor, the father of tech. Do you know LaTeX? Yes. Okay. The father. Okay. And he is also the father of algorithmic analysis, the analysis of algorithms. And he's a great mathematician. So he wrote The Art of Programming, that is 6, 7 books. I don't remember the name. And he wrote many algorithms. Okay. Well, so this is a great mathematician and a very great programmer, of course. The journal asked him to write a special issue where he had to solve this task. Write a program that accepts one input, that is a file, okay, a text file. And he need to process this file and as output produce the first. Oh, I'm sorry. It takes the input, a file and a number. Okay. You need to process the file and then print the most frequent words, the most n frequent words sorted. Okay. So if I say that the number is 10, I need to print the most 10 frequent words. Okay. With the first is the most frequent one, and then the second one, the third one, and so on and so forth. Okay. That was the task. Is it clear, the task? Well, he wrote in Pascal. Do you know this story? No? Okay. The printout of the program was 10 pages long, very well documented, and he invented also a new data structure suitable for this task. Okay. And another guy that is not famous as Donald Knuth solved the same task with 6 lines of bash. Okay. That's the power of shell. So those 6 lines, I write it here, is something like tr is another Unix command that is translate. Okay. So it is very useful when you need to convert one chart to another one. Okay. Through a text. It's very efficient. So tr-cc, then I'll comment. So capital A dash capital Z, lowercase a dash lowercase z. So with this line, it was translating the complement of this set. So everything that is not a word, basically, everything that is not a letter, a comma, an exclamation mark, numbers, to a new line. Okay. And it was squeezed, multi-repetition, for example, comma, space, they were squeezed into one new line. Okay, so for example, this one and the space were collapsed into just one new line, empty line. Hello, okay, was left as it is. Comma, space, again squeezed into new line, word as it is, exclamation mark, new line. Okay. So at the end of this process, you have one word per line. And what was not a letter disappeared. Okay. This was fed to another process, exploiting the pipe. Then if you need to count the frequency of a word, you want to do it case insensitive. Okay. So how can you perform this in a case insensitive way? Well, I can convert everything either to uppercase or to lowercase. Okay. I decide to do it to everything to lowercase. Okay. Then he did something that is blocking because awk was not developed yet. So he did a sort and sort and unique minus C. Did you explain yesterday, right? Okay. A sort is needed because unique checks just 2 consecutive lines. So if you want to remove repetition, you need to do a sort. Okay. These 2 lines can be solved with awk. Okay, in one step. Okay, but this is the original. And after you have counted how many times each word appears, you can sort numerically and in the reverse order, such that the most frequent is the first one. Okay, and then you can print. You have to print the first n words. Okay, this was an argument to a script that we will explain later how to handle script, and use it set. So this is the number of lines, okay, and q. So sed number q means print the first n lines and then quit. This can be used like head minus n, that number, okay. 1, 2, 3, 4, 5, 6. 6 lines, actually. Can be just 1 line, okay. But this is the power of the shell. You can perform complicated tasks in a very easy way. Okay? Since it is so powerful, so flexible, okay, it is convenient to store your script, store your command in a script, okay, in a text where you can reuse the same commands for different tasks. You can improve, you can change, you can customize. Yesterday you have seen kind of a bash script. So you put a command inside a file, and then you were running it saying bash, the name of the file. Okay. It works. What's wrong with that? Well, because bash is not the only one shell that exists. For example, if you print the content of the file /etc/shells in your laptop, you will likely see more than one shell, not just bash. Okay. Bash is born again shell, okay, but there exists a Z shell, fish shell, cheese shell. I don't remember if I already said Z shell, whatever.
Dash or bash in mine.
Sorry?
In mine, in my output for etc shells, I have sh dash bash or bash.
Yeah. Okay. I have more. Okay. So they basically do the same stuff, but syntax is different, maybe different between each one shell. The treatment of regular expressions may be different between one and the other. So if you have a script where there are some bash command, but you don't know which shell you have to use, can be problematic. Okay. So is there a way to kind of engrave in your script which shell or which interpreter you should use? Yes, of course. So a bash script begins with the sign for a comment, okay. Exclamation mark. So this combination of characters is called shebang. Okay. And then the interpreter with the full path being bash. Can you read from the back? Yes? No? Yes, great. Then I can write, for example, my script, okay, or maybe do. Bin bash. Okay. And we need one step more. Okay. Once we have done this, to make it executable, to make it runnable, I need to do one step more. Okay. Do you know what this step is?
You mean the permission to be an executable?
Great. All of you knows that? You don't. Okay. So let me do the hello world for bash, okay? And then you may play with more interesting script. So here there are two schools. One that, two philosophies, if you will. One that wants a .sh at the end of the file, okay? And one that say no .sh. Why? Well, first of all, Linux doesn't care, okay, because the type of a file is not understood by the extension of the name, like in Windows. Linux knows the type of a file through, you can query it through a command called file. So if I say file and then the name of a file, it will print out what type of file it is and how does it work. Linux looks the first bytes of your file, also called magic bytes, okay? And according to the type of bytes, it can understand if it is a JPEG, if it is a Word document, if it is a PDF, a bash script, okay? If you want to dig a bit into this, that sounds like magic, you have to type man magic. That's how it works, okay? So at the beginning, I like .sh because when I see the name, me human understand that is a shell script likely, okay? The other school says, well, a bash script should be not different from other commands like cat, sed, awk. Okay, so why I need to put .sh? Okay, choose the one that you prefer. So you have seen yesterday that you can echo out something through the command echo, okay? And echo appends a new line at the end of the string that you wrote automatically, okay? Questions on this? Okay. Did you open your text editor, wrote something? Okay. Then, if I want to make it executable, what means executable? It means that I can run it. Okay. How can I check if a file is executable or not? ls -l, and for example, a file, prints me this. Okay, let's try to understand what it means. Okay. Dash r w dash r dash dash r dash dash. What does it mean? So the first dash tells the type kind of a file. Okay. In Linux, everything is a file. If it is not a file, it's a process. Okay. Directories are files as well, a particular type of file. Your hard drive is seen as a file, another type of file. So if I say ls in this, I don't have folder here. Let me decrease the font. Okay, so you see that things that are in blue that are folders, the first char is a D for directory. Okay, so here the first one defines the type of the file. Okay, this is a directory. Then we have 9 spaces, 9 spots, 9 where can be present some letters, R, W, X, okay, and those can be repeated 3 times, okay. R means read, W means write, X means executable, okay. So these 9 placeholders defines the permissions of a file. What is repeated 3 times? So the sequence read, write, and execute can be repeated 3 times. Why? So the first one refers to the owner. The first 3 refers to the owner of the file, which is set here, specified here. In this case, Alberto. My username is the owner of this file text.txt. Okay, and in this case, the owner can read the file, can modify it, and can eventually execute it. Okay. Then, in Linux, user can belong to groups. Okay. We do not enter into details of groups, okay? But for example, if you want to run a game on Linux, you must be part, your username must be part of the user of the group game, okay? If you want to let your sound be available, your username must be part of the group sound, so on and so forth, okay? And so the second free char defines the permissions to all the users that belong to the group to which the owner belongs. Okay, so in this case, there is a group named Alberto. Okay, so all the users that belong to group Alberto, in this case, can just read this file. Okay, they cannot modify it. Okay, neither execute. Okay. And then the last 3 is for others. Okay, people that do not belong to my groups. Okay, to my group. They can read as well. Okay, this file, for example, can just be read and written by me, full stop. Okay. All other people, they cannot either read it, they cannot open it. Okay. Okay. Questions so far? Okay. Yes, no? Okay. Then there are these numbers. Do you know what these numbers are? These numbers are the number of hard links to that file or folder. Okay? When you create a folder like this one, typically you have at least 2 hard links. You see that inside Trento there are no folders. Okay? Why there are 2 hard links? Well, one hard link is the name of the folder itself. And the other one is when you are inside the folder, dot. Do you remember from yesterday that dot is the current directory? Okay? So this is the second hard link. It does the hard link for performance reasons. Okay? If I create another folder inside, the number of hard link will increase. Oops. Now it's free. Why free? Well, because when I'm inside Trento and inside the folder I just created, Trento is reachable through dot dot. Okay, this is the kind of the third hard link to this folder. Okay, never mind, we don't care. But just to explain what these numbers are. Okay. So if I say testing 10, I can infer that there are several subfolders. Okay. In fact, if we go, I don't know, testing, I see that there are 7 subfolders. Okay. The owner of the file, the group. Then this is the size in bytes. Okay. Know that all the folders have the same size. Okay. Because a folder is a special type of file. Okay. And its size is almost independent of the number of files and the type of how big files are. Actually, if you have many files, at a certain point, I don't remember when, the size of the folder may increase. But this is not the size of the folder as you may have in mind. So the sum of the size of all the files inside the folder. Okay. So a folder is just kind of a link to another tree. So you know that the file system in Linux is a tree, bottom up, okay, upside down. So the root is the root folder. Okay. Under this one, you may have many folders. You have seen home, you may have dev, so on and so forth. Then you have subfolders. With subfolders, so on and so forth. It is like a tree, okay? But on top, there is this root. And then you have subfolders that goes through the bottom. Okay. If you are curious that you want to know what these folders are, dev, ATC, TMP, OPT, home, on your distribution, you know that there are many Linux flavors, many Linux distributions. Okay, each one has its own philosophy. Okay, if you are curious to know, you can read man hierarchy, man hier. This will tell you, according to your Linux distribution, what these folders are meant. Okay, and then the timestamp when this was last modified or created. Okay, questions? Let me go back where it was my. Let's go back here. How can I set the executable permission to my script? Okay. Well, first of all, you have to ask yourself who should be able to execute it. Me? All the world? Me and the group? Okay, just the others? So suppose that you want that just you should be able to run this script. The command that you have to issue is change mode of of the file. And what you should do? Well, just me, the user, should add the executable permission. Okay? And then where we have to do. Okay? On which file or files. Now, apart the fact that hello became green, now you see that the X appeared in the first 3 spots, okay? In the permission of the owner, okay? All the others, not. If you are a bit lazy and you don't care, you can simply write chmod plus X. This will grant executable permission to all the 3 categories, the owner, the group, and the others. Okay. Now you see that X appeared in all the 3 categories. As you can add a permission, you can remove a permission. Instead of using plus, you can use minus. Okay. So read is R, write is W, executable is X. So you can, and just for sake of completeness, so the owner is U, the group is G, the others are O. Okay, so you can use, for example, chmod UG plus X. Okay. Well, now I say I just want to remove to the others the executable permission. I can say, Eleonora, do you guess what can I say?
Sorry?
If I want to remove the executable permission to the others.
Minus O, no, minus, no, O minus X.
Wonderful. Okay? Great. Perfect. Okay. Now, question so far, it's trivial. Again, for the sake of completeness, read, write, and executable as also a number. So you can say, you can see chmod 555 and the file, okay, or 500, okay. What does it mean? So executable is number 1. Write is 2, and read is 4. Okay. So 5 is the combination you see from read and execute. Okay. If you want to let that, this is again the owner, the permission of the owner, the group, and the others. If you want that you are the only one who can read and execute it, 0 means no permissions. Okay. If you want that the owner can read, execute, and modify it, can you guess what should I write here? 7. Great. Okay? That's it. Now we have set the right permission. Just for curiosity, let's ask to Linux, hey Linux, according to you, what type of file is this one? Hello SH, well, say it is born again shell script. Bash is born again shell. Okay. ASCII text, and it is executable. Okay? Well, let's try to run it. Hello.sh. Okay. Oh, hello sh, comma not found. Oh, come on. How? Why you don't find it? It is there, right? do you know where the commands that the shell knows are? So the functionality, the behavior of a shell is is defined through some environment variables. Okay. So in a script, when you program, likely you have variables. Okay. That you set some values, then you can do some math on it or whatever. In Bash, you can have kind of two types of variables: environment variables and local variables. Okay. These environment variables are set every time you open a terminal. Okay. So for example, if you type env, you see the variables, the environment variables that are set. Okay. So the first one is ls colors. There is a nice article from, I think it is Watson, the cluster in Cambridge maybe, that they speed up ls by a factor of 30 changing these colors. Okay. Just maybe this is for the sysadmin if they are interested. So they got, there were many people complaining about that ls on folders with many files and subfolders were slow. Okay, it was slow. They dig into that, and they found that removing this huge table of ls and keeping just few of that, they got a speed up of 1 order of magnitude. Okay. But this is some environmental variables, environment variables. Okay. There is one that is important, that is relevant for what we're going to see, is this path. Okay. So some commands on a shell are built in. Okay. So for example, cd is built in for performance reasons. Other commands, like, I don't know, unique, sort, tr, or they are there, okay, but they are not built in inside the shell. They are somewhere in your file system, okay. You know what a file system is. Who doesn't know what a file system is? So your hard drive is like a wardrobe, okay. The file system is an empty wardrobe, okay, just a box. The file system is like as you put the shelves, how you organize your stuff, okay, and how can you store it and how can retrieve, very roughly, okay. So the file system is how and where your files are located on your hard drive, okay. As you will learn from the next days, dealing with file system is the slowest thing that you can do when you do high-performance computing. Okay. Nevertheless, sometimes you have to deal with that. So path is a variable that you can see that is slash home Alberto PT source tipora column home Alberto PT lib meson 0.51 bin column kcache grind, so on and so forth. Okay, so it is a list of paths, full paths in my hard drive. Okay, where when I invoke a command, if it is not built in, Bash will start looking for it in order. So it will first look into home Alberto PT source tipora Linux -x64. It will see, suppose that I run sort, okay. I want to run sort, it go there. Is sort there? No. Go to the next one, so on and so forth, until it find one. Is clear? The first match, when it find the first one, it stops. It chooses that one. So you may have different versions of the same command, in two different folders. Well, the first one that is encountered is pick. Okay. Questions? So where is hello.sh? Hello.sh is in TMP, but TMP is not in my path. Okay, so that's why Bash told me hello.sh command not found, because it went through all the paths in my environment variable called path, okay, and it didn't find it. So how can I run this executable? Well, two choices. One is I can add TMP to my path, okay, but it doesn't make sense. The second one is to let Bash, tell Bash, please don't go through all the paths. I'll tell you where it is. And it is the current folder / hello.sh. So dot is a hard link to /tmp. So dot / is a full path. So Bash will not go through the paths listed in the environment variable called path. Is it clear? Yes? Okay. Now I can run it. Hello world. Okay. It works. Questions? Okay. So I told you that in Linux everything is a file. If it is not a file, it's a process. Okay. Each process has a unique identifying number, okay, also called process ID, PID. Okay, it's a number. So in this moment, this shell, this terminal, white terminal, is running on a process with a given number. Marianne told you yesterday that if you want to access the value of a variable, you have to prepend with $. The name of the variable must be prepended with a $sign, right? You need to add a leading $sign. So do you know which is the name of the variable in which is stored the process ID of this process? Is clear the question? So I want to know the process ID on which this shell is running. Well, the name of the process, the name of the variable storing the number of the process ID is $. So if I want to access I want to see the content of this variable, how can I access the content of that variable? $sign. So $$ means the value of the variable named $. So if I say echo $, gives me the process ID of this terminal. Okay, that is in this case this one. So if I keep repeating, it is the same. Okay. If I open a different terminal, it will have a different process. Okay? A different process ID. Is it clear? Why I'm telling you that? Well, because when you run a script, that script is run on a different process. If you will, a subshell is opened, and inside that, the script is run, and then that process is killed. And you go back through here. Why is this relevant? Because what is the behavior of the environment variables? Environment variables, so we have my my subshell here. Okay, this is my terminal. Okay, it opens a subshell with a different process ID. The script runs, and then you go back here. Okay, is it clear the workflow? Environment variables are inherited by the subshells. So it means that all the environment variables defined at this level are known on all the subshell. And also if this subshell spawns another subshell, environment variables go this way. But they don't go upwards. Okay? So for example, let's open our let us print the process ID of the subshell. And then suppose that I say I change the value of an environment variable. Okay? And then I run the script. So print hello world, print a different process ID, but then if I'm at this level, I ask to print the value of the path. It is not changed. Okay? But? Oh yes, let's do another script. Let's say, let's call print path. So now I create another script that prints the path, and that script is called from this. So I put myself in this situation. So I expect at this level to see that path is /tmp. Okay? Let's see. Okay, so environment variables go downwards, not upwards. Okay, so you can set the environment variable of a subshell, but the subshell cannot change environment variables of the father. Is it clear?
Okay.
Yes. Okay, thank you. And indeed, there is one easy way to change the environment variable of a subscript of a subshell. And let's add here that I say echo. So I first print the path that according to this script is, then I change it, that I invoke another script. Okay. So at the beginning the path is like that one, then I change it, and then it is like that. If I say path equal, then maybe echo will not work. Oh, perfect. So I can prepend to my executable the definition of some environment of some variables, and it means run hello.sh, okay, on a subshell, and in this subshell the variable path has that value, okay, but just for this one. So you are setting here. You are not changing path to people at this level, but at this level, okay. So you see that according to hello.sh, the path is people, then it changes again, and for the subshell is TMP. Okay? Is it clear? Okay. I just 2 minutes. How many minutes do you have before the break? I'm late. Half hour. 10:30. Oh, perfect. Okay. Oh, wonderful. Okay. So pay attention that bash has some cumbersome syntax. You are not allowed to put a space between path. When you want to assign a value to a variable, you cannot put spaces between the name of the variable, equal, and the value. Why? I'll tell you that. I'll tell you why. So if you want to say that variable A has value 7, okay, in my script or somewhere else, I cannot put spaces. Why? Because if I say A, let's put a space here, A equals 7, bash thinks, oh, I need to run this command, and the variable A is set to empty. Okay. So if I do this, I think bash will tell me 7 command not found. Okay? If I put a space here, it says, okay, I need to run command A and pass equal 7 as argument, as option. This will tell me A command not found. Do you understand? Can you see that? That's why when you define a variable, you should not put spaces, okay? Now a question for you. It is a bit uncomfortable, the fact that environment variables goes just downwards. Because what if I need to set many environment variables to let my program run correctly, okay? Or I want to change all of them, all of that environment variables to let my bash works in a particular way, okay? Because it's uncomfortable, because up to now we just know that either we change, we type the value. So if I say here path equals /tmp, now many programs will not work here, okay? But you see env comma not found. Oops.
By the way, now hello.sh will work without depending the path.
My path is that way, okay? So suppose that every time that I need to run a program, I need to change 10 of this environment variable. That is uncomfortable, right? because I cannot set the values of these environment variables in a script. Okay? Because once that script is done, environment variables at the upper level are not changed. Okay.
I have a question. If now you close this shell and you open another one, path is the normal one?
Yes.
Okay. So dash profile is not a normal dash file.
That's where I want to arrive. Okay. So there is another type of bash script that are not meant to be run, but they are meant to be sourced. Okay. Are files where you just define variables. You don't produce output. Usually you don't do computation. You may do something, but okay. And are files that when they are sourced, they do not spawn. They do not open a subshell. So the environment variables are defined. Okay, you can update, you can change your environment variables. Okay, as you would like. Okay, so if I do, for example, now this is the current path. Okay. So many commands doesn't work because they are not built in my shell. So shell is looking for them in the path, but path it is just /tmp. /tmp does not have all the command env, printf, whatever. And how can I actually set those environment variables? Well, when you open a terminal, there are several files that are sourced. Okay, the syntax it is just source or if you will source and the name of a file. Okay, instead of doing bash or /, you do source and the name of the file. There are files that just sysadmin should touch that set environment variables for all the users. Okay, and then each user can update the behavior of its own his or her shell through a couple of files. Okay, for bash they are located under your home. Their name is .bash rc and bash profile. Okay, so if you go in your home, you do ls -a, as Marianne told you, you will see that there is at least one of these two files. Okay, on a Linux, you likely have this one. On Mac, you likely have just this one. Okay, why? What is the difference? Well, the difference is if the shell is not interactive, like the login shell, bash will source this file if present. If the shell is interactive, it will source this one. Don't ask me why, but on Mac, shells are not interactive, are logging shells. So they want to source this file. So if you want to change the value, if you want to update the path, for example, you can say path equal. Oh, let's do here. I want to update, I want to prepend a path, people, to the environment variable path. Okay, I don't want to erase everything. Okay, such that then my shell doesn't work and I have to close it down and restart. I prepend this. Okay. As we have already seen, if I make this an executable script and then I execute it, it doesn't work because it will perform it in a subshell. Then when the subshell is finished, the environment variable, the modified version doesn't go upward. Okay. So this is the path, the current path. If I source the file, okay, now you see that people is there, okay?
So the standard bash files are only sourced when you log in, and that's the only thing that's happening.
When the shell is opened, the files are sourced every time. Yes, by default. There are some files that are sourced that are located in /etc whatever that set some variables worldwide for all the users, and after that they will look for, if present, to this or this. Okay.
But I can write them on my own.
Yes. 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 So if I source it again, oops, what I did. Oh. Yeah. I sourced that many times and I go people, okay?
In the HPC, you have to set dash.rc or
well, depends, yes. Usually on a cluster, you use module load, you use modules. Modules are another programming language, I've written a different language, that they manipulate the environment variables of path, LD library path, C path, or may also. And so module load, I don't know, Intel compiler, will prepend the path to where the Intel compiler has been installed to the environment variable path. Okay? So let's do it. Module avail. Okay? Okay. Ecco, this is the path that I have when I log in. Okay. When I do module load, for example, I want to test GCC 9.1, what happens? It happens, okay, the path where GCC 9.1 has been, where the executable of GCC 9.1 is installed, is prepended to my environment variable path. Okay, there's nothing magic. It's just they change the value of some environment variables, and now, since the first found wins, if I say GCC -1 version, it doesn't work. Guys, why? Oh. Okay, so this is the syntax. So you see that prepend path, that prepend to this variable, this path, okay, prepend to another environment variable that you will learn maybe next days, LD library path, this path, to man path. When you say man something, okay, there is an environment variable called man path, where man will look for if there is a man manual for that command, okay, info path, and then change to this environment variable cc, cxx, and for a compiler to this value. Okay. So indeed, there is not an alias to GCC. So in this folder, that's why it was not found. Okay. So I chose the wrong module. Okay. But I hope you get the point. Okay. Questions? Yes.
But if I want to have a new executable to my part in the cluster,
Yes.
should I modify both dash RC?
No. Bash RC is enough. Okay. Because it is Linux. Okay. If you were on a Mac, as you likely have to touch bash profile. Okay. I can show you. So this is what I add to my bash RC. I source a file that I name exports. Okay, you don't know what export is. I will tell you in a short while. Aliases, functions. Okay, I export this variable from command. Okay, when you execute a command, okay, this is on Linux. The title of the shell is provided by the output of this command. Okay. So I wanted to have the full path where I was, so because it was not set by default. Okay. So every time that I run a command, like cd somewhere else, the title of my window is updated correctly. Okay. Then this is MATLAB style history. Then source git prompt. Okay, I will come back on this. Okay, and so you can do what you want on your bash RC. Okay, you customize the behavior of your shell, changing things in this file. Note that it doesn't echo. It doesn't produce output. Okay, a file that is sourced usually shouldn't produce any output. Okay, it doesn't run things. Okay. Questions? Yes.
So you wrote all your environmental path modifications in different source files.
Yes.
And you are calling jet files, and that's the clean thing. That's a cleaner version way to do
So
that.
for example. You know, because I usually use a different shell. Okay, so it's to reuse the same stuff. So the syntax, for example, of functions are the same for the Z shell. Okay, so I can in Z shell I just say source that file instead of copy and paste the stuff. Okay, fish shell has a different syntax. Okay, so I can reuse. Yes.
Where do we find the bash RC?
In your home. No, the dot. Yes, it is hidden. Thank you. So.
Yeah. Okay. I got it.
Okay. Okay. Oh, okay. People that works on a terminal are lazy, and you strive to be lazy. Okay. You should strive to be lazy. Use the tab as much as you can. You know what tab is? Tab completion. Okay. So people, since it is very common to source a file, there is a kind of an alias for source. You can write source file.sh or simply dot. Okay. Dot file.sh. Let's do it. so my path is clean, I can simply source using dot instead of writing source, and the result is the same. Okay. So up to now you have seen dot as many meanings. Dot may mean current directory depending on the context. Okay. Dot can be a wild card that may represent any character, but only one, if inside a regular expression, as Marianne showed you yesterday. It can be it can mean source. Okay. Questions? Now, how can I create a new environment variable? Okay. So if I say just a equal 10, that's not an environment variable. Okay. If I want that a equal 10 is an environment variable, I have two choices. I can say, for example, a equal 10, and then export a, or in just one step, export a equal 10. Okay. Now there is I don't remember if it was introduced in batch 3, but at the beginning, to change the value of an environment variable, you had to export it, and this has something that you can read everywhere. Okay. Actually, there is no need to export. If a is already an environment variable, you don't need to do export again, okay, as we did for the path. But I like, nevertheless, that because it makes clear that you are working with environment variables. Okay. So readability of a code is something that you should engrave in your mind that will help yourself and others to reduce the bugs. Okay. So even though I know that path is an environment variable, I like to write export path equal, okay, such that the first guy that comes to my laptop and doesn't know all that stuff, he knows that export means I'm working with environment variable. Okay? Questions? You can avoid export when you run a script with a different environment variable as we did before. Path equals something space dot slash hello dot sh. Okay. For example, the number of OpenMP threads in some scripts, in some executables, can be set by changing an environment variable called OMP num threads. Okay. Questions? Easy? Was it new? Is something that you already knew? Yes, no? I assume that is the best answer for me, so that the lecture was super. Now, in a file that should be sourced, you can put several things among exports the variables. There are aliases and functions. Okay. I recommend not to use aliases. Okay. So the syntax is very easy, like alias then the name of alias, for example, LL, equal without spaces because we know why, between commas. So, for example, if I find that I find myself in using ls minus l many times, okay, it may be useful to write an alias like that. So I write LL, and it is expanded by bash through ls minus l. Okay, can be comfortable, but sometimes fingers are faster than your mind. So if you put many alias, like for example, you know that rm doesn't ask you a confirmation. Okay, rm a file, it does it, full stop. So if you are say, okay, I alias rm to rm minus I, lowercase. I stands for interactive. So rm this file. Are you sure you want to delete this file? So if you are used to like something like that, fingers are faster than your mind. So you then open, you connect to the cluster, you do rm something because you are sure that then you will ask a confirmation. But in that class is not aliased to rm minus I. You are fucked. Okay. So they may be common, they may be useful, but do not abuse. Okay, that's a warning. No.
But you can put an alias for rm equals rm minus I for all by default.
That's your, yes, of course, you can do whatever you want.
How can we solve this?
Of what?
How can we avoid this problem using function? We cannot, I guess.
No. I mean functions. If you write this as a function, you are in this. It's
saying that using aliases is
for
dangerous.
yeah, for dangerous commands it may be dangerous. And but I still prefer functions among aliases because in a shell script aliases are not expanded, while functions yes. So if you write an alias for her, not ls minus l or different commands, in a script the aliases are not expanded, just on the interactive level they are expanded, while functions can be used both at this level or inside other scripts. Okay, so this is why generally functions may be better than aliases. Okay, and the syntax of a function is very simple. It is just the name of the function, open close, and then between curly braces you put the comment, the commands that you have to do. Okay, full stop.
How we define what the function returns? It returns something.
What do you mean by return? Is something that it prints on screen, or what it actually returns?
Yeah, exactly. So
The
using like in Python or C.
Bash is not Python. Okay, so
It just does what is inside the braces.
yes, yes. Okay, so if you want to modify a variable inside a function, well, this variable should be known before you enter that variable. The variable modify the value of the variable, and in the script after you have called in the script you run the function calling simply function name. Okay, so in your script, suppose that you first you source the file where that function is defined. Okay, then you define a equal whatever. Inside your function, you perform all what you have to do is say a equals 7. Then here,
Okay. So basically means that I cannot assign the result of a function to anything.
oh yes, you can,
And so what will be the
but
content of that variable?
but it's not. You don't use a return. You may use a kind of a trick that you can output what you want to return, and then you assign to a variable the output of something. So, for example, if you want to say, suppose this does echo 7, there are two ways to assign to a variable the output of something. Old ways with a backtick. Okay, it is. Okay. So, for example, now A will contain the output of ls minus L. I do not recommend this, but this is the old style. Okay. So if you go on Stack Overflow, whatever, you may find this syntax. That's why I tell you. Since bash 3, if I remember correctly, they used this syntax. Dollar, open, close. Okay. Why it is better this one? Because this can be nested. Suppose you have another program, I don't know, call it find path, whatever. Okay, this produce as output a path that can be used by ls minus L. Okay. You saw an example yesterday. Okay.
Not nested, but using this notation.
Perfect. Okay, so you already know. While with simple backticks, there is no way that Bash can understand that something is nested. Okay. Just before the break, yes.
So if I write that thing inside a .sh file and I source that, is the same thing as
No.
exporting that same stuff in the upper shell?
Oh, yes. If you source this, then you will have a variable A at the upper level with this value, yes.
And if instead of sourcing a file that contains that, I export that line,
It's the same.
it's the same.
It's the same, yes. No, let's do the break now. Okay. So, guys, this afternoon I have to leave a bit earlier. So, if you don't mind, can we compress a bit no, not the lunch time, just the breaks, the coffee breaks. Okay, if you don't mind, I would say just 15 minutes break is enough. Okay, great. Grazie, scusa. No questions. I have a question for you. What type of variable, if any, are the variables in Bash? What type of variable are variables in Bash? What is the type of the variables, if any?
Strings.
Yes, they are, strictly speaking, untyped, but they are strings, always. Okay. So if you say a equals 7 is a string with the char 7. In particular context, they may be interpreted as numbers, okay, but in very special conditions. So for example, if I say if I write this, can you guess what will be the output? No. So variables are interpreted as string, basically. Okay. So if I say a equals 7 plus 6, it writes 7 plus 6. Okay. Don't do floating point operations in Bash. Okay. Don't do it. If you really need, there is BC, but please don't do floating point operation in Bash. Okay. You can do just integer operation, and the syntax is funny because you have to do the double round parentheses. Okay. Inside the double parentheses, you can perform math operation. And if you want to get the output of that, you have to add a leading dollar sign. Okay? So if I change now my script, dollar 7 plus 6. For here, the space is don't matter. Okay, it is important that you put a space between the variable name, equal sign, and the value. Okay. If I use this syntax, now I perform the math. Okay, just integer operations. Okay, don't do floating point, please. Okay, floating point are not supported. Actually, the double round parentheses they are a bit more powerful. We just let you do some integer operations. They open kind of a C style environment. So for example, I can use plus plus. So I can say dollar dollar okay, plus plus is not bash. Okay, but inside the double parentheses, I can use some features of the C language. Okay, or I can use, for example, the ternary operator. Do you know? Condition if true, if false. You know the syntax. Condition, A greater than B, question mark, what to do if this condition is true, colon, what to do if the condition is false. Okay. Pay attention that run parentheses have many can be found in many places, but like dot, have different meanings, have different behavior. If I do this, before that, another environment variable, sorry for jump, that controls what is written before the cursor. So now you see Alberto at Sagix TMP $. Okay. This is controlled by a variable, environment variable, named PS1. Okay. Now, let me change this to that. Okay. So my terminal is cleaner. So now I'm here, TMP. If I do GD, what happens? Where I am? Run parentheses, open a subshell. So the subshell goes in home, then it exit, and I left back where I was. Okay. So run parentheses, open a subshell. Okay. That runs on a different process, inherits my environment variable, so on and so forth. Braces behave differently. Okay. To cut a long story short, they do not open a new process, a new subshell. A semicolon at the end of is mandatory. Okay. And also the space at the end. So this is mandatory, this semicolon, this space is mandatory. Now I am my own. Okay. Why I'm telling you that? Well, first of all, because curly braces define a code block. Okay. So suppose in your script you have many lines of code that you want to redirect to an output file. You want to redirect the output to a file. According to what you have seen yesterday, the solution would be like, first of all, remove the output file, right? Then write one line of code, append to file. Another line of code, append to file, right? Is it clear what I'm writing? Yes? Okay. What is bad in this snippet of code? Can you read from the back? Should I increase the font? No, okay. Well, first of all, there is this repetition. Repetitions, usually, you cannot avoid repetitions at all, but usually repetitions suggest you that it's a bad design. Okay. Why it is a bad design? Well, because you can put typos here, here, and here. Okay. So suppose you put rm, a file that doesn't exist, or a wrong file, you remove the other one, you append to that way. What would be a solution for that? Well, a solution for that use a code block, curly brace, and the end of a code block you simply redirect. This will overwrite what was before. Okay, you don't have to remove because it does it. Okay, it cleans the content, and you have no repetitions. Okay. Run parentheses, new subshell. Curly braces, code block, very useful in scripts to redirect output and errors to files. Okay.
So whenever we use the braces, we have to end with the semicolon.
Oh, if you put in this yes, if you want to put a semicolon on the same line of the last command, put a semicolon and a space. Okay. On a script, I suggest to put on a new line. That's easier.
In a way, it's similar like the for loop. When you do it multiple lines, you don't need the semicolon. While
Yes,
if you
yes,
check
yes,
the
yes, yes. So the for loop that you are seeing yesterday is for, say, I in whatever, do. You can put this do on the same line, but since for and do are both keywords, you cannot have two keywords in the same command. So, or you do put do on a new line, or you say semicolon do. Okay? So indeed, thanks for asking this. There are 3 ways that you can put in a sequence different commands on a shell. You have seen the pipes, right? So command 1, pipe, command 2, where the output becomes the input of the second one. Then there are these 2 that you can have command 1, semicolon, command 2, command 1, double semicolon. No, sorry. It's with the double ampersand. Yes, it's with double ampersand. Right? Is it right with double ampersand, right? Simple semicolon. That means run this. And then run that one. Okay. Or you say run this, and if and only if this one was successful, run the second one. Okay. I read a story. I don't know if it is true, but there was a script that had CD somewhere, RM minus RF star. Okay. The story tells that the guy who wrote that put a typo over there. CD was not successful, and in a bash script, if a program fails, the script doesn't stop, goes to the next one. Okay, so if CD fails, it means that inside that script you didn't move to the right folder, and then you start executing the second command that was remove everything. Okay, I don't know if that was run as root, but you can imagine. So a better way to do this would be, for example, combine CD and RM with the double ampersand, such that if I successfully moved to the right place, I run rm minus rf. Okay? Okay, let's go back to our parentheses. Okay. Run parentheses, subshell. Okay. Curly braces, code block. Another use of run parentheses. What about arrays in Bash? How can I have an array? How can I define an array? Do you know the syntax? A equal, okay, without spaces, run parentheses. And then the values are separated by spaces. Okay? What if you want a value? And remember, they are always string, even though they are numbers, they are seen as strings. Okay. What if I want a string with a space? So I don't want that a phrase is divided into many words. So that element must be a phrase. So if I want that this element, I want hello world, okay, and this must be one element, not two elements. Okay. Eleonora did the right movement with the fingers. I need to put a quotes, double or single quote. Okay. Questions? How can I print the values? Well, I access, for example, the first element start from 0. Sorry for Tangai, but Bash is C style. Okay. We start from 0. And the syntax is this one. $, curly brace, name of the variable, this access the value of the first element in the array A. Okay? How can I understand this syntax? Well, the fact that we told you that you access the value of a variable through putting a leading $sign, actually this syntax, name of the variable, is a shortcut. The real syntax is $. And between curly braces, the name of the variable. This is the real. This is just a shortcut, okay? But the official one is this one, okay? So if I need to access the value of a variable, $sign and curly braces. And yes?
No, so the opened, no, not, in the definition of the array, we use the round scope.
Yes.
In that place, it's not a subshell because
Yes.
it's after the equal without a space.
Yes, yes.
Okay.
So, as I told you, the run parentheses have many meanings many different behaviors depending on the context, okay? But you have to know all of them. So this is the official syntax to access the value of a content. Then the element of an array, as like in C, it is simply the name of the variable, the element between square brackets. Okay. If I want to access all the elements, I can put a star there or at. Okay. There is a slight difference between using at or star depending on the context, because with a star you get just one string with all the values. With at, you get kind of one element at a time. Okay. Let's do an example. Let's comment this out. So my array is 1, 2, 4, hello world. Okay. Echo out 0. Okay, let's first do this. Can I run this? Where? Oh, yes. Sorry. Okay, so the first element is 1. Okay. If you think to separate values through commas, okay, you get that the first value is 1 comma. Okay? Elements are separated by space. Okay? You can go to, like in Python, when you are inside the run parentheses, square bracket, curly braces, indentation doesn't matter. The same here in Bash. Okay? So you can go to the next line. Okay? Do you know printf? Who doesn't know printf? You? And you, I guess, or you know printf. So you will see a lot of printf in C. It's a way to print something on the screen. But there is also printf in Bash. Okay, so printf usually in C is a function. So you have printf between parentheses, first a string, comma, and then some other input that you want to print. In Bash, the syntax is almost the same, but without the run parentheses, without the call to a function. So in Bash, printf, inside printf, the first string, you can put some placeholder that can be substituted later. So for example, %s is a placeholder for a string. Okay. \n, new line. Okay. And then I can say $a at. Okay. So printf is more portable than echo. Echo is easier to use. Okay. If you have some, we are kind of in a pathological cases, but sometimes they happen. If the variable that you are going to write, its value contains some special chars that echo can understand in some weird behavior, you get a wrong output. Printf is much more robust on that. So if you get familiar with printf, it's good. It's better for you than using echo. Okay. And in this case, it allows you to print one element of to print all the elements of the array without doing a loop. Okay. So in this case, let's try to do printf, placeholder for a string, new line, a at. Okay. Oh yes, there is this first echo. sorry, it prints me one element at a time. It returns me one element at a time. Okay? Great. There are no bound checking. Okay. So if I ask to echo or printf, let's do printf. A of 99, for example. No problem. Bash doesn't complain. It gives you an empty string. Okay. Also, if I ask to print me the value of a variable that doesn't exist, no problem. I don't complain. Just empty string. Okay? Questions on this? Now, with this syntax, I get access to all the elements. Okay. If I want to know how long is an array, I put an hash there. This will tell me how long is the array. So printf, let's do this. Okay. Four elements. Okay. Very good.
So it also works for when using the star notation.
Yes. Okay. Of course, if you need to access the elements not just for printing using printf, but you want to loop on that in all the elements, the syntax will be for the I in all the elements, or star if you prefer, do, and then use $i. Okay?
What if I have to do for I in like range length of A? Does it work the same? What is the word for range?
Sec.
Sec.
Sec. So if you use sec or this will return.
One on the end.
Yes.
You wouldn't have directly the actual elements in your loop.
No.
So it depends what you want to do.
Yes. I know that coming from programming like C, whatever, you are more used to this kind of loops. They may be trickier to use. Okay. If you think a bit, I'm almost sure that you can reshape your loop into this form that is easier to handle. Okay. But you are free to do what you want. Okay. And then in this case, you will have a for I in the output of this command. Okay. You have to increment I at each loop, right? +1. In this case, at the end of the loop, you can exploit the double run parentheses. Okay.
In principle, if someone wants to do a for loop kind of from 1 to 10, you can either use the curly brackets.
Oh yes,
One.
thank you. Yes, yes. One way, but yes, there is the brace expansion. So if you want to do a range, a loop from 1 to 10, you can use this brace expansion. Curly brace 1 dot dot the end. You can combine also a dot dot h, for example. You will have 1a, 2a, 3a, so on and so forth. Then 1b, 2b, whatever. But I didn't find a way to put this into the brace expansion. I was not able to exploit the length of an array into a brace expansion. If you find a way, let me know. Okay. Yes.
Sorry, I did not understand. So it is compulsory to do E plus 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 I.
Yes, because
Compulsory.
yes, because
It doesn't know.
it doesn't know that you need to increment I by 1 at the end of the loop.
Okay.
Okay. So this is, let me write this in a cleaner way, exploiting brace expansion. So for I in 10, oh, in this case, not. Okay. Wait a minute. I think I'm wrong. You're right. If I do for I in sec, I don't need to do a plus plus I. You are right, because sec returns what was before. It was let's say sec. Where are we? Yes, you're right. You're right. Yes, I'm wrong. I'm sorry for confusing you. So
For it's not necessary.
sec. If you say for I in the output of sec 110, for example, as you can see here, you don't need to do plus plus I. I was wrong. I'm sorry.
While if you do for I in the first one with A,
You
do need it.
you don't need it. Okay.
You don't need
I don't need because at each iteration goes from first element, then the second element, then whatever. I was thinking to tell you about the while loop. I've confused myself. I'm sorry. You know that a for loop can be written also a while condition. Okay. So you can say while I less than the length of the array. In that case, I have to do plus plus I. I'm sorry for confusing. Very sorry. Questions? A question for you. How can I pass arguments to my script? No.
Each word after the script call have an identifier, if I remember correctly,
Yes.
based on position,
Yes.
then you can call them clicking the script.
Yes. So if I want to pass an argument to a script, I simply say this will be my first argument, this the second, this is the third, okay. This will be the fourth one, okay. And inside my script, I can access the first argument by $1, the second by $2, the third by $3. Pay attention that $1 is a shortcut to dollar, open curly brace, 1, close curly brace. Okay. If you have 10 arguments, if you say then if you're used to this syntax, this is wrong. This will be $1 and a 0. If you are used to the extended version, you cannot do that mistake. Okay. So it is not clear how Bash understand $varname 2. Suppose you have two variables, varname and varname2. It is not clear in this way if it will understand to access varname2 or access varname and append a 2. So my suggestion is, like with export, spend a bit more time, put the curly braces, and you don't go wrong. Okay? You don't do mistakes.
Just a comment on this last part. This is also useful when someone is trying to create a file, for example, in a for loop. So you want to say some kind of temporary _1 dot dot.
Yes.
Depending on what is kind of the dot, understand if that $I would be a variable.
Yes. Yes.
If there is an underscore, it thinks that is all.
I like this notation because it's clear both for Bash and both for you what is the variable. Okay, and this clear.
So it's a lot of mistakes.
Yes. 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 Okay, and as you have seen, if you do a mistake in Bash, it's not like, I don't know, in C or in Python, it crashes, the program stops. It keeps going. Okay. So, for example, printf first argument is $1. Okay. Let me call this people. Okay. So there are not many first. First argument is people. Okay. $1, first argument. $2, second argument. Okay. If I don't put arguments, Bash doesn't complain. Empty string. Okay. So how can I check if a script needs to have an argument? Okay, needs some arguments. How can I do that? Well, I may check that the number of arguments that I got is sufficient. Okay, is enough. Is the right number. Okay. Just for completeness, can you guess what is $0? Oh, yeah. Thank you. $0 is $var.sh. So it is how you invoked the script. Okay. If I invoke the script /tmp with the full path var.sh people, $0 is /tmp var.sh. Okay. So if you want to get just the name of the script, usually you have to apply base name of $0 and you have to run this on a subshell. So first run base name $0, and then you retain the output with the leading $sign. Base name cleans. Okay. So usually, when you use $0, you may want to use base name as well. Questions? The number of arguments is stored in a variable named hash. Okay. With the hashtag. So 1, 2, 3, 4. The number of arguments is 4. Okay, so $hash is the number of arguments. So if I want to check if I have the right number or enough arguments in my script, I can exploit that variable to know how many arguments I got. And do you know how to test in Bash? Bash has if a condition. How can I test if the condition is true or false? Square brackets. Okay. Pay attention that here again the syntax is a bit cumbersome. Square bracket, mandatory white space. My condition, mandatory white space, square bracket. So this is how you test. Okay. The test is performed through square bracket, mandatory white spaces. Okay. How can I write the condition? Okay. Usually you have there may be a lot of conditions. Okay. You can say man test because you can check if a file exists, if a file is a file, if a file is a directory, if a file is executable, if a path exists. You may want to check numerical values, if a value is equal, if a value is less than, is less or equal, greater than, greater or equal. Okay. Just for so there is no need to that you remember all of them. I don't remember all of them, for sure. If you want to know how can I test if a file is executable in Bash, Google knows better than us. Okay. But the syntax, like for example, if you want to know if the number of arguments is greater than 2, for example, I can say there is a white space, greater than dash GT, greater than, I don't know, 4, again space. Okay. Greater than is GT, greater or equal is GA, less than LT, less or equal LE, equal. Okay. How can I exploit this test, as Marianne anticipated, with an if? If is a construct that allows me to control the workflow of my logic, of my thought. So the syntax is if my condition, then okay, I may have an else if, okay, that is elif, again another condition, okay. I may have else, okay. At the end of the if, oh, I can simply have just if then, and full stop. At the end of the if, better, the end of the if is phi, the fi, the inverse of if fi. This is how you close an if statement, okay. Suppose that you got the wrong number of arguments, okay. So if $hash less than 4, my program cannot work, okay. How can I translate this I cannot work in bash? How can I throw an error? You cannot throw an error, you exit, okay. Exit. And put a number different from 0. Okay? So exit free. Let's try the word if. If I really need many arguments, okay. If my argument number of arguments is less than 10, then I can say okay, and then exit free. Okay, because 0, usually exit 0 means everything went fine. Okay, there were errors. If yes, which kind of errors? Okay, there is just one number that tells me no errors, that is 0. Infinite numbers to tell me that something went wrong. So I got not enough arguments aborting, but how can I know that my program failed? Kind of. Perfect. How can I check the exit status of my program? Windows throws away that return number. Okay, Linux is a bit smarter. It doesn't throw away the return number of a program, but it stores it in a variable named question mark. Okay. In a variable named question mark, I have the return value of the last command. Okay. So how can I print the value stored in that variable? Who tells me? Okay, which is a shortcut for this that I prefer. Free, okay, the exit number, okay. if I redo this command, what I get? Perfect. I got 0 because printf went fine. Okay? Okay. Just a recommendation. Nothing wrong with this exit free. Okay? But again, to improve readability, if you have a long script, define some variables at the beginning of your script, like variable named wrong number of arguments equal to 3. I can do this. In my script, I say r wrong and args equal 3. Okay. And then way below, I exit with the name of this variable. Okay. Such that if you don't see, or the script is, this if condition is long, you see exit r wrong and args, you read it, you understand what's going on. You understand that this is an error with related to the wrong number of arguments. Okay. At the end, you have exit free. Okay. But this is much more readable. Okay. Improve readability, you will reduce the bugs. Okay. If you have more than one argument, more than one error that you want to handle, of course, different values. Okay, there are some numbers that are kind of yes, suggested. Okay, I don't remember. If you want to go into the detail, I recommend the book Advanced Bash Scripting Guide. It's kind of 1,000 pages book.
Like the most common one is 1 when it fails, right?
Yes, different from 0, of course.
Yeah, sure.
Yes, maybe it may make sense that from 1, then 2, then 3, then whatever, okay, but something different from 0. Or you can choose that, I don't know, errors related to a part of argument are multiple, are from 0 to 10. Errors related to another part goes from 11 to 19, I don't know. Then you can choose. What I want to say, I don't remember. Do you have questions, guys? If you don't have questions, I will. Can we possiamo spegnere il proiettore e alzare questo? I will write on a blackboard how can I handle all the arguments by hand with the options, introducing the case statement. Okay, I think it is easier if I write it slowly on the blackboard so you can see the syntax. Okay, and that's kind of conclude basic knowledge of bash scripting. Okay. So you know the case statement in C. Is there a case statement in Fortran? So if you need to check a lot of if, it is easier using a case statement. So where you check if the variable, you say for which variable you need to check, and then you have all the cases. So the syntax for a case statement is case, okay, the variable that I want to check, better the value of the variable, okay, in keywords, And then you can say the value a, for example. If my variable is a, do what I want. Okay. I end with a double semicolon. Okay. If var is equal to a, if the value of var is equal to a, do this, and I know where to stop with a double semicolon. Okay. If my var is dash dash help, suppose that this var are my, I'm looping on my arguments. If my argument is dash dash help, I may just print out how my program works. X is 0, example, double semicolon. Okay? And I end the case like with the if, with the reverse of case, that is ASAC. Case. Right, yes?
The fact that we use double line for when the option is a word and only a single, I don't know the name of the character, line, when there is a, minus L, but when we use the long minus H, but minus L.
Yes.
Is a convention.
Kind of. Yes. Usually you have the short option with just single dash and the long option with double dash. But not all programs. So not always.
So we could write something which does not respect that.
Yes.
Will work.
Yes. Nobody will kill you. Okay.
Okay.
So suppose that I want to say I can accept either minus H or dash dash help. Okay. I can have a kind of the or, okay, dash dash help or dash H. Print the documentation and exit. Okay? The syntax of the case statement is case variable in the cases, the value of the strings, okay, run parentheses, what you have to do in that case, and with a double semicolon. From bash 4, they introduced you can use this or ampersand with double. Okay, it's not clear to me why they needed to introduce that, but probably there were some corner cases. Okay, just to let you know. So you can see this or this. Just the end of a case statement, a case block. Questions? Yes.
So in that case, the value of the variable should have been dash dash help or just help?
Dash dash help. Well, depend. Okay. I introduced this to handle the arguments by hand. There are a bit more sophisticated way to handle arguments, that is get opt, that is older. Get opts with the S, that a bit newer, okay. But with them, it is very easy to handle this, the short options. Handling the long one, it's a bit messier, okay. But it will require me a bit more time to explain. While doing it by hand, you understand the concept, okay, and it is easier to handle this case, okay. So if you're interested, you can go on Google, say get ops. This is newer, should be recommended. With respect to this one, they have different syntax, okay, of course. So suppose that I want really to loop through all my arguments and see what I got, and for each of the options that I got, do something. Okay. What is the trick? The trick is, if this is my script, if you have these options, the trick is that you look just the first one, okay? And then you shift. You drop this out such that then the second one is again the first one. So you can do the case on $1, the first argument, okay? If $1 is equal to A, you do something, and then you do shift. Okay. You go to the next one, and you do this while my number of arguments are greater than 0. Space, 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 space. Okay. Why? Do. Done. Okay. Shift. This is $1, $2, $3, $4, $5. Okay. If I call shift, this becomes $1, $2, $3, $4. If I call shift again, $1, $2, $3, and the number of arguments here are 5, here 4, here 3. Okay, so with shift, you remove the arguments. You pass one at a time. Okay, so the case statement can be done just on what I wrote here, on $1. Okay. Suppose that with I don't know, minus s, I had the case. I do here. Minus s needs to read this argument. Okay, so like head minus n 3. Okay, there will be, if head is written in bash, there will be a case statement where if the argument is minus n, I need to read the next value and set some variables. Okay, is it clear? So I may want to pass an argument, an option, and a value associated to that option. Well, if I am this condition, $1 is minus s. I want to store this value into my variable, whatever. The value is $2, right? I'm looping on $1. So if $1 is this one, $2 is the value. Okay? Is it clear? These two must be processed together in this example. So this is $1, this is $2. That very good. Then I have to do 2 shifts, right? So shift, shift. Okay. Are you following? Yes.
And then do shift or so?
Yes, because this is related to this one, not to this one. Okay.
You're waiting two arguments in a
Yes. Yes.
Sorry, I don't want to be out of topic, but how can bash commands be agnostic with respect to the order of the flags that you use? Because we can use them in a different order, right? We can say minus n, minus d, or minus d, minus n.
Yes. Well, this is
It works like this.
this works perfectly because you get minus d. If you minus d will set some variables. Okay. Then you said minus m. I don't remember. Minus m will be here. We will set other variables. Then the real program begins after that one. So your real program will be if that variable is that
Things are not broken, you know, all this while. I mean, it doesn't matter. Like first, you know that I don't know. Argument 1 should be 2 and argument 3 should be 4. It doesn't matter as long as you have the right information.
Okay. Okay.
so suppose
Get broken down.
So it's the letter that defines the right place for each argument, basically.
yes. Yes. If you want, if you have many short options, okay, that you want, like with minus L, with ls, they can do minus LRT, okay. This is the same of minus L, minus R, minus T, okay. Short options can be combined together. But if you want to allow this feature, this doesn't work. To allow this feature, you need to use these two guys. Okay? But the concept is more or less the same. Then you will have a case statement, okay, with what you have to do. Is it clear how can pass through all the arguments? Yes, no? Yes, raise your hands.
You said that you cannot code the contracted version of LRT by means of case. But if you multiply the number of choices, you are able to process also the arguments in that.
I mean, you have to do it by hand, so all the combinations can be a lot. Yes, yes. Yes, you can do it. Just say that this is easier exploiting the future of these guys. So these guys has a syntax like I can have L that doesn't accept an argument. I can have, I don't know, R that doesn't accept an argument. I can have, I don't know, N that accept an argument. I can have help that can accept an argument. Okay. So you feed to GetOps or GetOps this kind of information, and he understands that if the argument is L, is R, is N. If N, it will need to read also the second argument. It's the syntax. I mean, the concept is the same. You have a case statement. You have to do different things for different cases. How you get the value is a bit different. Okay, but I like this one because this is general, easier to implement, okay, and you understand also a new command that is shift. Okay. Last thing, what I want, I feed with a wrong argument, and I want to report the error. Cases. Let me delete this. Usually the last one case is this one, whatever, okay? You enter this if the argument is not one of the cases that you have listed, okay? So if you feed with a wrong option, you will enter this case, okay? How can I want to print an error message that say, you inserted what I wrote and say invalid option. how can I do it? Okay. Printf. Okay. Wrong option. What is? Perfect. $1. Okay.
You have been able to parse through the order's case
Yes.
all the meaningful comments.
Yes. This is what I was interested, that you know what is the wrong option, because here we are looping with $1. So if I want to access the value, it is $1. Okay. I want to reuse the value, it's the same that I'm using here. Okay. Why quotes? Okay. Very quickly, if I have a variable like this one, let comment. If a variable like this one, a, so if I want to have a variable that has, I don't know, oh, I write on the blackboard, I'm sorry. A equal hello, many spaces, word. Okay. If I do echo or printf simply $A will be hello world. Multiple spaces will be collapsed into one. So why with double quotes it preserves formatting. Okay? So I will have hello, all the spaces that I put word. Okay? Is clear? Just if you have a fancy formatting on your variable, use the double quotes to preserve that formatting. Just one thing about the error output. Am I doing wrong or am I doing good? Just saying printf, you moron, this option is not known. I can exit with a different error, with a number different from 0, yes. But it's something that I can improve. Do you remember standard input, standard output, a standard error? Okay. So this is something that should be put on standard error. Okay. But printf writes on standard output. So I can say, hey, the standard output, please redirect it to standard error. Okay, so %2 is the address of 2 of standard error. Okay. Maybe we return on this after lunch. Okay. See you at 2. Okay.
No,
at 1. At 1. At 1. I'm used to have lunch at 1. Sorry, that's why.